Hello viewers, if you're watching this video for the first time, please endeavor to click the subscribe button. Alright, thank you. Now in our today's video we're going to be looking at the laws of logarithm. So starting with the first law is called the product law. When we have multiplication of the values in the logarithm, it implies summation of the values of the logarithmic values. So if we have, for instance, we have log of 2y to the base of 2, it simply means log of 2 to base 2 plus log of y to base 2. Then the second law, which is quotient law, division to subtraction. So when we have division of logarithms, it implies the difference between the values. For instance, we have log of 2 over y to the base of 2. We can break it down to be log of 2 to base 2 minus log of y to base 2. Going over to the third law. In this third law, whenever we're looking for the logarithm of a number with an exponent, the logarithm of number with an exponent, this exponent is going to move over to the front of the log. Then we have n log of m to base a. So for instance, we have logarithm of 3 squared to base 3 rather, is simply going to be equal to the 2 as an exponent. We're going to move over here, so I have 2 log of 3 to base 3. Moving over to the fourth law. The fourth law, I call it the zeroth law, that the logarithm of 1 to any base is equal to 0. The logarithm of 1 to any base equals 0. So if it's logarithm of 1 to base 10, it will still give us 0. If it's logarithm of 1 to base 2, the answer is also going to be 0. No matter the base used, as long as you're looking for the logarithm of 1, it is definitely going to be 0. So we'll go over to the fifth law. The fifth law is called the unit law. The unit law. The logarithm of a number to its same base is equal to 1. The logarithm of a number to its base is equal to 1. So whenever the number and the base are equal or they're the same, it gives us 1. If for instance we have log of 2 to base 2 is going to be 1, log of 5 to base 5 is also going to be 1. So moving over to the sixth law. Now in the sixth law, I call it the change of base. Change of base. Whenever you are given a base in a particular logarithm and then you want to change it to another base, this is the law you use to do that. So let's say we have log of a to the base of b, log of a to the base of b, and then you're not satisfied with the base you have here. Let's say you want to change the base to c. In order to do that, you say log to base c over log to base c. A will come as the numerator and then b as the denominator. This is the change of base law. So if for instance we have log of 3 to base 2 and then you want to change the base, let's say you want to change the base to 5, so it's going to be log to base 5 over log to base 5. 3 will stand as the numerator, while 2 as the denominator. Alright, moving over to the next law. The seventh law we have here, which is called the reciprocal law. Reciprocal law. Now the reciprocal law is gotten from the change of base law. It's gotten from the change of base law. Now in this law, if we want to change the base, we want to change the base to a. The number here a and the base is b. You want to change the base to a. This is what's going to happen. Just like what we did here, it's going to be log to base a over log to base a. Then a are the numerator and b denominator. And if you remember the unit law, logarithm of a number to its base, the same base, is going to be 1 over log of b to base a. Then moving over to the eighth law, which have log of a to the base of 1 over b. Log of a to the base of 1 over b. Now we have a fractional base. Now in this case, what's going to happen here is that if I want to change this base 1 over b to b, if I want to change the base 1 over b to become b, which is a whole number, I can write it as log base b over log in base b. A come as the numerator and then 1 over b come as the denominator, equal to log of a to base b over log, of course 1 over b is sent as b to the power of -1. Then have our base b. The law we used here, if you look at the law we used over here, the exponents here moved over to the front of the logarithm. The same thing is going to apply here. So it's going to be log, same thing is going to apply here. It's going to be log of a to base b over -1 log of b to base b, equal to log of a to base b over, of course you know that log b to the base of b is 1, so over here we're left with -1, and of course when we divide through, we're going to have minus log of a to base b. So what this